Completing our previous derivation, the derivation was related to the force vibration. The force vibration was induced by a harmonic force. That harmonic force was F naught sin of omega t. Through this method, and we had also studied two methods, particular integral and complementary method. Through the complementary method, we had solved the solution, and second method was the solution for the differential equation. The second method was that is a particular integral, and again particular integral, by finding the solution of the second degree differential equation through particular integral, we had two options, rather one is analytical and second one is a graphical. In previous lecture, we had completed the solution of the second degree differential equation through the particular integral by the analytical method. And in addition to that, we will be solving today, we had solved the value of tan phi in the form of c omega upon k minus m omega square. The equation number was 5 in our previous lecture. Similarly, we had also solved the equation for capital H, that is amplitude. It was equal to f naught upon k minus m omega square cos of phi plus c omega sin of phi. Now we will further solve the equation for the values of sin phi and the cos phi as well. For that we will have to learn, or we have to remind our Pythagoras theorem. We know that the tangent of theta is equal to perpendicular upon base. Similarly, sin of theta is equal to perpendicular upon hypotenuse. Similarly, cos of theta equal to base upon hypotenuse. By taking all these things into account, since we have tangent of phi equal to c omega upon m square, so may I call it as p upon b. May I call it as p upon b, means this c omega becomes our perpendicular and b is your k minus m omega square. From I have been making a triangle like that. From this triangle, your perpendicular is your c omega and base is your k minus m omega square. So this is your base and this is your perpendicular. So from this base and perpendicular, we can find out the hypotenuse, means this square and this square, root of that will be the hypotenuse. Now we have been successful in finding out perpendicular, base and hypotenuse. So we can easily find out the sine of phi and cos of phi. We know sine of phi is equal to perpendicular upon hypotenuse. So your perpendicular is your c omega and your hypotenuse is your c omega square minus k minus m minus plus k minus m omega square the whole square and root. So from these two values, sin phi and cos phi, we have find out from this triangle. Now we have the relationship capital X equal to f naught, which we have solved in our previous lecture. Capital X equal to f naught upon k minus m omega square cos of phi plus m c omega into sin of phi. This is your equation number 6. Now put the value of cos phi and sin phi from sin phi this value and cos phi this value over here and over here in equation number 6. By putting these values and solving it further, we will get this solution. So capital the solution after putting the values of sin phi and cos phi, we will get capital X equal to f naught upon root of c omega cos square plus k minus m omega square ka whole square and complete ka root. Now we can do one more thing. We can divide k over here and similarly k over here. So f naught divided by k. Similarly, in the lower portion also we can divide by k. So this portion comes over here. The equation number, we can name the equation as equation number 7. So m omega square upon k equal to, we can also write this equation. m को मैंने नीचे लिया, k by m omega square मेरा ऊपर ऐसे कैसे, k by m omega square upon k by m को मैंने ओमेगा n का नाम दे दिया and omega n equal to k by m root of k by m, ये मुझे मालूम है, that is why I have put k omega. So m omega square may I write it as omega upon omega n का whole square. I keep it over here. Similarly मेरे पास second term है c omega c omega upon k. Basically I am trying to find out the values of c omega upon k and k minus m omega square upon k. So we are trying to find out those values. So C omega upon K, I can write this equation as CC upon CC into CC को ऊपर से मल्टीप्लाई किया और नीचे मल्टीप्लाई किया. CC upon CC, C omega upon K मेरा ऐसे कैसे बने रहता है. तो इसको मैंने रीअरेंज कर दिया. C upon CC, C upon CC, इस CC को मैंने ओमेगा के साथ लगा दिया. CC into ओमेगा upon K. C upon CC आपको मालूम है जीटा होता है, यानी कि डैम्पिंग फैक्टर होता है. तो दूसरी बात, सीसी का वैल्यू आपको मालूम है रूट ऑफ 2 टू ट्वाइस ऑफ रूट ऑफ km होता है. तो मैंने सीसी का वैल्यू यहाँ पे ट्वाइस ऑफ रूट ऑफ km रख दिया. k मेरा यहाँ पे ऐसे कैसे है, उसको मैंने छेड़ा नहीं है. यहाँ सिमिलरली ओमेगा मेरा ऐसे कैसे है. नाउ व्हाट आई डिड, 2 मेरा यहाँ पे ऐसे, जीटा मेरा यहाँ पे ऐसे, ओमेगा यहाँ पे ऐसे. ये जो k है, k से k कट गया, m मेरा नीचे ले आया, रूट ऑफ k बाय m नीचे की तरफ आ गया. रीअरेंज किया इक्वेशन को. अगेन रूट ऑफ k बाय m इज ओमेगा n. सो आई कैन राइट द कंप्लीट इक्वेशन एज 2 जीटा ओमेगा अपॉन ओमेगा एंड दैट वाज इक्वल टू c ओमेगा अपॉन k. लेट अस मूव टू आवर सेकंड स्लाइड. सो these are the values. I will keep it over here. I will further use these values in our second slide, means to solving the equation. Now I had solved the equation in my in today's lecture that capital X equal to f naught upon k. k से हमने ऊपर भी मल्टीप्लाई किया था, नीचे भी मल्टीप्लाई किया था. और ये वाला जो इक्वेशन है ये हमने कल ऑलरेडी सॉल्व कर चुके हैं हम लोग. आज के सेशन में सिर्फ इतना हमने ये किया है कि k से ऊपर डिवाइड किया और k से नीचे डिवाइड किया, इससे ज्यादा कुछ भी नहीं है. सो व्हाट आई विल डू, C ओमेगा अपॉन K का जो वैल्यू मैंने निकाला है अभी आपके सामने, आई विल पुट दिस वैल्यू ओवर हियर. सिमिलरली आई विल पुट m ओमेगा स्क्वायर अपॉन K का जो वैल्यू है यहाँ पे मैं वो वैल्यू पुट कर दूंगा. सो व्हाट आई पुट द वैल्यू ऑफ C ओमेगा अपॉन K एंड ओमेगा फ्रॉम स्टेप नंबर 5 एंड 6, जो कि अभी हमने यहाँ पे निकाले. नाउ what I do, capital X equal to f naught upon K, is it as it is. So C omega upon K I have already find out in 2 zeta omega upon omega square plus 1 minus m omega square upon K that I had already I have just calculated it, that m omega square upon K is equal to omega upon omega to the whole square. So this putting this value. Now, where we can also another term get introduced into that. What is that new term? So the new term is f naught upon k. This is known as your x first. X first means that it is the deflection due to f naught at the zero frequency or the static condition. Means the system has not yet started. So this is a deflection at the very first sight. You can say like that. So the equation, I will name this equation in the form of zeta omega and omega n. This equation I name it as equation number 8. Similarly, I will try to find out the value of phi and tan phi in the form of zeta omega and omega n. So what do I do? Tan phi, I know tan phi, I have already find out in the previous lecture. Tan phi equal to c omega upon k 1 minus m omega square upon k. So C omega upon K I have calculated just now 2 zeta omega upon omega n. Similarly 1 minus omega omega n the whole square the complete. So I named it as equation number 9. I have just done one thing. I have calculated tan phi in terms of zeta omega and omega n. Nothing more than that. So next one, so the final solution, if I need to write out the final solution in the form of zeta and omega and omega n. So I know xp, that was the previous equation for the particular integral, and our basic equation for the particular integral was xp equal to capital X sin of omega t minus phi. So put the value of x over here from equation number 8. From equation number 8, put the value of capital X in the so as to find out the final solution, that is particular integral, that is your xp. So while you are putting the value of capital X as f naught upon k divided by 2 zeta omega upon omega n complete का whole square plus 1 minus omega upon omega n का whole square का complete का square. This equation number 10. Moreover, you can also write f naught upon k as x as being x first. So this is the another way to write out the equation. Let us see. Now we have been successful in calculating or completing the solution. So this is the final solution. This is the final solution to the particular integral or the particular method. Now we will go for the second method. That second method is your graphical method. So let us understand the graphical method. How do we calculate the values through the graphical method? For I've already written on the board also the graphical method for finding out the particular integral, that is xp, phi and x, that we have just calculated through the analytical method. Now we'll try to find it out through the graph. How do we do it? Let us see. So we know the basic equation for the particular integral, that is xp equal to capital X sine of omega t minus phi. So just differentiate it. We have also done it in the earlier case also. Xp integral equal to omega x cos of omega t minus phi. We can also write it as in the form of sine by adding pi by 2 to that equation. Similarly, xp double dot will be equal to minus omega square x sine of this value. So we can also make it as positive by adding pi to that, so that the equation becomes positive. Now we know the basic equation for the simple harmonic force for a spring mass damper system actuated by a harmonic force, that is F naught sine of omega t, m xp double dot plus c xp dot plus k xp equal to F naught sine of omega t. Just put the value of xp double dot from equation from this step number 3. Similarly, xp dot from step number 2. Similarly, xp from step number 1 in the equation number 2. I have already named this in equation number 2 in my previous lecture. So I kept the name of the equation as it is, equation number 2. So after putting these values and solving the equation, so I reach to the conclusion F naught sine of omega t plus m omega square x sine of omega t minus phi minus c omega x sine of omega t minus phi plus pi by 2 minus k x sine of omega t minus phi equal to 0. So from this equation we can very well view that the four forces are into the picture which are applicable on the spring mass damper system actuated by a simple harmonic force. So even this equation also shows that four forces are there in the picture. Even we had studied in the FBD also, free body diagram, the four forces were into the picture. What were those forces? The first force was the harmonic force. It was an external excitation force which was actuating the system, which was giving a direction to the system. Second force was the inertial force. This force was came into the picture due to the D-Lambert principle. Similarly, third one is your damping force. This force came into the picture due to a damper we have put into the system. And fourth force is your spring force, which came into the picture due to the restoring force offered by the spring. Now we will try to draw a vector diagram through all these four forces. Now let us see how do we draw the diagram by these four forces. First force is here F naught sine of omega t. Since this force is positive in nature, so this is your F naught red line. This is your F naught, and this is in the first quadrant. So this is your sine. This is omega t is the angle. So this is the way how we draw it. F naught sine of omega t. This is your F naught. Second point, m omega square x. This is the magnitude, and sine of omega t minus phi. M omega square x, this is yellow line. M omega square x, this is the magnitude, and omega t minus phi, this is the angle. Now third point, minus sine omega x means this is the magnitude but is in the opposite direction. Vector sum के अंदर आपको मालूम है पॉजिटिव राइट इधर जा रहा है तो नेगेटिव आपको अपोजिट जाएगा. So c omega t minus phi. But this is at an angle of plus to 90 degree. Omega t minus phi के 90 पे प्लस है, so it is in the 90. So sin आपका जो है 90 के एंगल पे नेगेटिव फोर्थ क्वाड्रेंट में होगा. So that is why I have drawn it in the fourth quadrant and at an angle of 90 degree. अगर मैं इस डायरेक्शन में बना देता तो इस डायरेक्शन में साइन जो है पॉजिटिव होता सेकंड क्वाड्रेंट में. 90 में इस डायरेक्शन में भी बना सकता था, बट सेकंड क्वाड्रेंट में मेरा जो साइन है वो पॉजिटिव होता है, तो वो पॉसिबल नहीं है क्योंकि मेरे पास यहाँ पे जो वैल्यू है साइन का वो नेगेटिव है, मैग्नीट्यूड मेरा नेगेटिव है. So that is why I have drawn it 90 degree in the fourth quadrant because sign is negative in the fourth quadrant. Similarly, minus kx sin of omega t minus phi. Similarly, so it should sign is also negative in the third quadrant, but in the opposite direction. Kx is in the opposite direction than that of your m omega square x because it is negative in nature. So magnitude negative, obviously negative magnitude है तो इसके opposite जाएगा. So this is the force diagram in the form of the how do we draw a diagram from the equation. Now we'll try to go for a vector diagram by adding all these vectors so as to find out the vector sum. Moreover, the vector sum of all these forces must be equal to 0 so that the system must be stable or is in the equilibrium. Let us see. So how do we do it? So this is your white line shows your kx. So this is the white line. Similarly, c omega x, this is your damper for damping force. White line is your from here to here, this is your spring force. F naught, this is your harmonic force. Yellow line shows your that is inertial force. And by adding all these things, we will have a vector sum. And we will name this one as this is your O, this point O to A, this is your F naught, A to B, this is your inertial force, B to C, this is your damping force, and C to O is your spring force. Now we will do one more thing. We will drop a perpendicular from A on OC. The perpendicular is your AD. Drop a perpendicular AD on OC. Why do we drop the perpendicular? So as to solve it graphically for finding out the values of phi, capital X and XP also. So first we will try to find out the tan phi. So as to find out the tan phi, we know that the tan phi equal to AD upon OD. AD upon OD from triangle OAD. From triangle OAD, I must write it as from triangle OAD. From triangle OAD means perpendicular upon base. Perpendicular is your AD and base is your OD. So we can further write as AD मेरा ऐसे कैसे है, OD को मैं यहाँ से लिख सकता हूँ OC minus DC. So OC minus DC. So what is the value of AD? AD is equal to BC. So BC का वैल्यू है आपके पास C ओमेगा X. Similarly OC का वैल्यू है मेरे पास KX. OC मेरा टोटल स्प्रिंग फोर्स है यहाँ से यहाँ तक. So KX minus DC हो गया आपका m ओमेगा स्क्वायर x. तो x से x मेरा कैंसिल हो गया दोनों ऊपर से. k से मैं डिवाइड कर रहा हूं ऊपर भी और नीचे भी. तो k को दोनों को डिवाइड करूंगा इस इक्वेशन को, तो मेरे पास ये वाला इक्वेशन आ जाएगा c ओमेगा अपॉन k 1 माइनस m ओमेगा स्क्वायर अपॉन k. नाउ आई आल्सो नो फर्दर c ओमेगा अपॉन k. स्टेप नंबर 5 और 6 से अभी हमने सॉल्व किया नीचे. c ओमेगा अपॉन k को हम लोग 2 जीटा ओमेगा अपॉन ओमेगा लिख सकते हैं. सिमिलरली 1 माइनस m ओमेगा स्क्वायर अपॉन k को ओमेगा अपॉन ओमेगा का होल स्क्वायर भी लिख सकते हैं. So this is the way how to find out. The second point, similarly we can also find out capital X and XP also in the same way as that we have find out the value of tan. So I think you can do it at your own. If any problem is there, we can further discuss in the class. Thank you.